Hello 8th graders, this is Mr. Humphreys and we are starting a brand new chapter. Before we begin though, I want to kind of tell you what this chapter is going to be about. This chapter is about geometric reasoning. You are going to be using inductive and deductive reasoning throughout this chapter. In addition, the second part of this chapter is going to be talking about mathematical proofs. This chapter can get a little confusing and you may have some problems with it, and that's okay. Please ask. Please ask. So let's start with an example. I'm not going to go over anything about what we're doing now, except I just want you to figure out patterns on your own. Let's start with the first example. Find the next item in the pattern. In A, we have Monday, Wednesday, Friday. What's the next item in the pattern? What'd you get? It should be Sunday. Now, how'd you get that? Hopefully the pattern that you figured out was that alternating days of the week make up the pattern. So the answer here would be Sunday. Find the next term in this pattern. 3, 6, 9, 12, 15. What's the next number? Hopefully you figure out it should be 18. How'd you get that? We're talking about multiples of 3. Since we're talking about multiples of 3, the next number would be 18. All right, what would be the next item in this pattern? Hopefully you'd write an arrow that looks like that. In this pattern, the figures rotate clockwise approximately 45 degrees each time. Therefore, the next figure is the arrow that I have drawn. So let's explain what you just did. When several examples form a pattern, and you assume the pattern will continue, you have just used something called inductive reasoning. Let me kind of give you some background of what it means. Inductive reasoning is a process of concluding a general rule or principle is true. For example, suppose that you observe 50 bees and notice that all of them have 2 pairs of wings. When you conclude that all bees have 2 pairs of wings, you are using inductive reasoning. Now, in math, inductive reasoning is often used to develop geometric intuition. You're going to be using inductive reasoning in a lot of mathematical principles within geometry. So here's your first vocab word. Inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. You may use inductive reasoning to draw a conclusion from a pattern. So your next vocab word leads to this. A statement that you believe is true based on inductive reasoning is called a conjecture. A conjecture is that statement that you believe is true based on the inductive reasoning that you have observed. So here's example 2. Complete the conjecture. The product of an even number and an odd number is blank. Now the conjecture is that statement. So the first thing you have to do is use inductive reasoning to find a pattern or example. Always make your own examples. So in this problem, it says the product of an even and an odd number. So, multiply an even and an odd number together. Here we get 6. Okay? 2 times 5. Even and odd, that gives me 10. Even and odd, that gives me 12. 4 times 5, that gives me 20. So, the product of an even and odd number is what? Your conjecture then would be that it's even. Because each of these examples that you picked using inductive reasoning, that's the process. Your conjecture would prove that the product of an even and odd number is even. All right, the next example. The number of segments formed by n collinear points is blank. The number of segments formed by n collinear points is blank. So here's what you have to do. We're talking about segments. Collinear means they make a line. So let's start off with an example. Okay, how many segments did I just use? I made one segment. How? Well, how many points did I use? I used 2 points. And 2 points gave me 1 segment. Okay? Now, I'm going to use 3 points. They have to be collinear, remember. How many points did this give me? Well, it was 3. And segments, here's 1, here's 2, and the whole one is 3. So, here's what I'm going to do. 2 plus 1 equals 3. Because remember, the one big segment is still there. So now I'm going to use 4. 1, 2, 3, 4. So I still have the one big segment. I still have, looks like here, 1, 2. I still have my 2. Well then, I have 1, 2, 3. So I have one big one. I have this segment here. I have this segment here. And I have each of the 3 segments. So that gives me a total of 6. Is the sum of the whole numbers less than n? So if you looked, if I had 5, I added all the numbers less than that. All the whole numbers less than that. If I had 4, I added all the whole numbers less than that. If you had 18, you would add 17 plus 16 plus 15 and so on. Example number 3 is on page 75. So you don't need to write this entire thing down. I do want you to write the answer, but you don't have to write this entire problem. But do follow along and pay attention. To learn about migration behavior of California gray whales, biologists observed whales along 2 routes. For 7 days, they counted the number of whales seen along each route. Make a conjecture based on the data. Now, the red, if you can see up here, the red is the direct route. The shore route goes along the shore. That's the black dotted line. So look at I just want you to look at the data yourself and see if you can make your own conjecture. What do you think you'd write about the conjecture based on the data? Well, hopefully you realize that the shore route was much more used than the direct route. So since we're talking about migration, you would say as your conjecture that most California gray whales migrate along the shoreline. And that's your conjecture. And how'd you use that? You used inductive reasoning looking at a pattern. So, to show that a conjecture is always true, you must prove it. So, we're going to make this little table here. I love this. This is my favorite part about conjectures, is this. Inductive reasoning. To show that a conjecture is always true, you must prove it. To show that a conjecture is false, you only have to find one example in which the conjecture is not true. This is called a counterexample. Now that's a vocab word. You can write it down, but it's pretty easy. A counterexample is proving something false. All you have to do is prove one thing false, and you've just proved a counterexample. A counterexample can be, and if you want to write it underneath here, this may be good. A counterexample can be a drawing, a statement, or a number, like proving it mathematically. Example 4, this is our last one. Show that each conjecture is false by finding a counterexample. So for all positive numbers n, 1 divided by n is less than or equal to n. All you have to do are substitute values of in n to see if the conjecture holds true. If you start picking things and it's always true, then maybe the conjecture is always true. All it takes is one thing to enter, though, that it makes it false, then the entire conjecture is false. So let's just start picking numbers. Let's pick 1. 1 divided by 1 is less than or equal to 1. That's 1 is less than or equal to 1. That's true. Let's try 2. 1 divided by 2 is less than or equal to 2. Well, that's true. So, if you pick 3, 1 divided by 3 is less than or equal to 3. We're going in the wrong direction. So, let's try 0. 1 divided by 0. Well, you can't do that. Let's try half. 1 divided by a half is less than or equal to 1/2. Well, 1 divided by a half is 1 times 2, since we multiply by the reciprocal. So that's actually 2. A half goes into 1 2 times. So 2 is less than or equal to a half. That is incorrect. This is false. What you've just done is prove an example, a mathematical example, and that's good enough. So you just proved a counterexample. That's it. You've just proved that conjecture is false. Part B. For any 3 points in a plane, there are 3 lines that contain 2 of the points. So if you start drawing any 3 points in a plane, so you might think, okay, let's do that. Well, if I draw 2 points, that makes a line. 2 points, that makes a line. That's a really bad drawing. 2 points make a line. So you're like, there are 3 lines that contain 2 of the points. Well, you've just drawn 3 lines. But wait a minute. It doesn't talk about making a plane. It just says 3 points in a plane. So you might think to yourself, well, I thought they had to be non-collinear to make a plane. We're not making a plane. They're just 3 points in a plane. So we can draw 3 collinear points. They're in the same plane. Is that 3 lines? No. You've just proven that you can draw 3 collinear points that make 1 line. You've just proven by a drawing that this conjecture is false. And the last one is C. The temperature in Abilene, Texas never exceeds 100 degrees Fahrenheit during the months of March, April, and May. Now the title, there actually is a title here, this is in your book. The title actually says Monthly High Temps in degrees Fahrenheit in Abilene, Texas. So you have to prove a counterexample. The temperature in Abilene, Texas never exceeds 100 degrees during the months of March, April, and May. So let's look at March, 97. Nope, it works. April, yep, it works. Oh, May. May is 107 degrees. So you can, literally all you have to write is that your counterexample is that the temperature in May was 107 degrees. Therefore, you've just proved that that conjecture is false. Your 3 vocabulary words are inductive reasoning, conjecture, and counterexample.